This video is a quick cross product and right-hand rule. That's what RHR stands for, right-hand rule. This is a little quick reminder video. Okay, so I've already sort of started writing out some stuff. So the point is I want to know how to calculate the cross product between two vectors. I've got a vector A and a vector B, right? Here's A and B. And over here I say the order matters a lot. So what I'm asking for here is what is the cross product A cross B? That is, A is first and B is second. The reason the order matters is if you were to calculate the cross product B first and then cross with A, you actually get something related to the answer A cross B, but it's opposite. It's the opposite of the answer to A cross B. So B cross A is the opposite of A cross B. That's the sense in which the order matters. Okay, so doing the cross product involves discovering the magnitude of the answer, right? The answer is C, because presumably you know what A and B are. So the magnitude is calculated this way. You can see that everything in here is actually not a vector, right? So this is the size of the answer C, the size of one of the vectors A, the first vector, times the size of the second vector, times the sine of the angle between A and B. So here's something interesting to say, right? If the angle between A and B is 0, that is, the direction of A and the direction of B are actually the same direction, we say that those two vectors are parallel, right? If the angle, though, is 180 degrees instead, that means that the direction of A and the direction of B are opposite or anti-parallel, right? In those two cases, the sine of 0 is 0, and the sine of 180 degrees is also 0. I'll remind you what the sine wave looks like, where this position is the 90-degree angle, and this position is the 180-degree angle, and this is the sine of theta, and this is the theta axis, right? So those are the, oh, excuse me, no, I just drew that 100% wrong. I'm so sorry. Let me back this up. Okay, so this axis is the theta axis, and this actually is all 360 degrees. I'm so sorry. This right here is halfway around the circle, and this right here is none of the way along the circle. Excuse me. So you can see that the sine wave takes the value 0 at 0 degrees, and then it takes the value 0 again at 180 degrees. And then when you go all the way to 360, it takes the value 0 again, but you know that 360 degrees is all the way around, so it has the same value as 0. But anyways, according to this magnitude rule, if the vectors are parallel or anti-parallel, right? That is, if they point in the same direction or in opposite directions, you are always going to calculate that the answer is 0, simply because the magnitude is 0. But if the angle is neither 0 nor is it 180, then you're guaranteed that the magnitude of C is not going to be 0, right? You're just guaranteed that. But the direction is determined by the right-hand rule. Okay, so the magnitude is not going to be 0, but the magnitude is going to be given by this relationship. And notice that the sine of the angle theta is only going to be between 0 and 180. That is, the sine of theta is only strictly positive, right? So that's the sense in which I'm guaranteed that what I'm calculating is a positive magnitude for the vector C, or the answer C. Okay. So here's a situation of a vector A. It has some length and some units, right? It could be I don't know, a momentum or a distance or something. And then here is another vector b. It could be, I don't know, a force or something like that. So a and b do not have to have the same units. They don't have to be the same physical dimension, right? Okay. For example, if you want to calculate torque, that's R cross F, right? So this has physical dimensions of distance, and this has physical dimensions of force, right? So this is, for example, meters times newtons, or the Newton meter. Okay, so anyways, so let's think about A. A is drawn, it's in the plane of the screen, and of course I did that on purpose because it's easy to draw. And B is perfectly out of the screen. Can you see I drew it as the tip of an arrow? So I'm hoping that you've already understood this, but the tip of the arrow is as if you're looking at an arrow and your eyeball was here. So can you see that the tip of the arrow is a dot, and then the edge of the arrowhead is the circle, right? So that's the sense in which you are seeing the tip of an arrow. And of course, if you look from behind, so here is another person's eyeball, and if they're looking at the back of the arrow, what they're going to see instead is that cross. So this is the sense in which there is a vector that's pointed into the screen. Okay, so this is out of the screen. So A is in the plane, right? And B is out of the screen. So in this particular case, the angle is 90 degrees, because this could be like the z-axis, and this is some combination of x and y, right? And you can see that z is perpendicular to that combination of x, y. I mean, it's just geometrically perpendicular. So you're guaranteed that the angle is 90. All right, so the sine of 90 happens to be 1, right? If you look at this curve, here's 90 degrees, and you know the maximum value of the sine function happens to be 1. So the sine of 90 is 1. So that means that the answer to the magnitude of the vector c is going to be the magnitude of A times the magnitude of B times the sine of 90 degrees, which is just A times B in this case, because the sine of 90 is 1. You're multiplying by 1. All right, so if you know the magnitude of A and the magnitude of B, then you know the magnitude of C in this particular case, right? But what about the right-hand rule, right? The right-hand rule at this point gives us simply the direction of C. That's all it's going to do. It doesn't give us the magnitude, it gives us the direction. So how do we do the right-hand rule? So let me move these two vectors down so we can, so I'll copy, paste it here, and then I'll copy and paste that one here. All right, so, oh, I hope it, let's see. No, I guess it didn't. Interesting. Oh, here we go. So copy, and I'll paste here. Okay, not sure why I wasn't able to copy everything over in the okay, so here's the two vectors again. All right, so here's what you do. So in order to do the process, right, to do right-hand rule, put tails of the vectors together, right? But without changing directions. So what that means is grab your second vector and move it so that it appears to have the tail, right? Can you see that I put the tail of B at the tail of A, but I didn't change the direction of either A or B? So that's the first step, to do the right-hand rule. The second step, see, is to take right hand so actually let me take a flat right hand and point fingers in direction of the first vector. For us, since we want to calculate A cross B, the first vector is A, right? So we want to put our fingers of our flat right hand in the direction of A. So in that case, right, here is a flat right hand. I could imagine taking my right hand, here's the fingers, and here is the thumb, right? So here's the fingers, and here's the thumb of the right hand, and you can tell that the thumb is sort of pointed out of the screen and the fingers are pointed along the direction of A. Now the thing about your flat right hand is you want your thumb to be at right angles to your fingers, right? So another way to look at this is index, middle, ring, pinky, right? That's also a flat right hand, right? So here's the thumb and sort of the palm of the hand, right? So it can look like this. No, that's actually the left hand, isn't it? So what I need to do, let me erase that and put knuckles instead, right? In order for this to be the right hand, knuckle, 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 knuckle. So here's the thumbnail, here are the fingernails, right? So that's another view of the right hand, right? Here, oh, that's actually the left hand as well, isn't it? Oops. Let me erase this and make a right hand. So a right hand, oh yeah, here's how I can do it. So here's the wrist, and here is the thumb, the thumbnail. Here is the back of the hand with a knuckle and an index finger, a ring finger, oops, a birdie finger, ring finger, pinky finger, right? And it goes into the palm like this. And this is the back of the hand, and this is the palm, right? So the right hand. But can you see that in order to go from this picture to this picture, you rotate the wrist. But can you see that the fingers still point in the direction of A, which is up towards the right? You can see the fingers are pointing up towards the right. But because you can rotate your wrist, your thumb can either point out, or your thumb can point up to the left, or your thumb can point inwards, or your thumb can point down to the right, can't it? So I'm talking about your thumb. So what you do is you rotate the wrist until right hand fingers can curl towards B. Can you see that this picture right here, oh, no, not that one. Actually, the fingers will be able to curl towards B only if, can you see it's got to be this way? So the right hand, if the thumb points this way, and what we're looking at is the palm of the hand. Here's the pinky, the ring finger, the middle finger, the index finger. Can you see that at this point, your thumb points this way, and these fingers can start in the direction of A, but curl up to the direction of B. But in this picture right here, where your thumb points out of the page or out of the screen, your fingers can't curl towards B because your right hand, your index finger can't turn up and point out of the page, right? And in this case, if we're looking at the back of the hand, can you see that your right hand fingers, they won't curl up and point out of the screen, right? Your right hand won't do it. And if you turn your thumb so that it's pointed into the screen, then your right hand fingers, they can't point out of the screen. They're going to only be able to point sort of down to the right. But if you orient your hand this way with your thumb pointed down to the right, this is the only way that your right hand can comfortably curl its fingers from A towards B. That's why it's called the right hand rule. And the answer is down to the right. That is C points down to the right. So if I was to, let me paste again. So here is that vector B, and roughly speaking, the vector A, right, points this way. That was A. And it turns out that the answer to C is that one. It's not any other direction. It's this one. And this was given to us by trying to figure out how to orient our right hand so that our right hand fingers, if you start flat with a flat hand, your right hand fingers can curl from A to B easily. And the way your thumb points is the answer to the cross product. Okay.